Howdy folks, today I wanted to talk about my Anomaly project that's been going on for absolutely ever. Not done yet, probably, I don't know. Pretty close as usual. But I just wanted to go over some stuff I've been doing. Been getting a lot of comments from other DIYers appreciating the information I put out there, so I just figured, hey, let's put out some more information and people can dive in and do whatever the heck they want. So what we got here on my monitor here is, this is Fusion 360. Just kind of go over some of the workflow I've been doing, technology I have in here, and whatever else. So I have a couple models. These are my latest ones. We're on model 313. And what is this, 311 here? Yeah. Um, you know, to be honest, I had to learn a lot of 3D modeling, and that took a long time. Plus, shell ergonomics, as you can see, took a lot of work to get this, well, what I consider to be okay. Could be better, but it's pretty okay. There's a lot of things that matter in terms of this design and tuning the IEM. So if we turn on the backplate, you can kind of see just this is the closed backed version. Open backed version would look something like this one, right? And we'll just go over some stuff here. So by the way, here's the graph, my latest graph right here. So we can see that we have about 6.6, 6.5 decibels of ear gain, and it's centered right about 2.4-ish K, so a little bit forward, and this is something I've been working on for a long time. So the area between about 1,000 hertz right here and, well, let's see, how do I do it like this? Yeah. So about between 1K and say 2.5. This area matters greatly in terms of the shout factor, how bold and forward vocals and instruments are. So this part right here, which is a little bit hard to see in terms of the slope, it's better to do this with compensation type graphs so you can see exactly sort of the decibel change between tunings. But this is okay. It's a little bit forward. And the way that I would want to combat that forwardness is by a nice healthy mid bass and bass shelf back over in this area. We don't have an 8K peak really, and that's by design. I really don't like 8K peaks. In a previous video, I said that you can kind of tell when a driver is over dampened because you'll see a big trough before the 8K peak and then after a lot of times. So you could tell that I have the acoustics pretty cool on this, and there's absolutely no smoothing. See, no smoothing right there. So that's just a smooth treble response. And we can see that in terms of the mids, which right around here, we're crossing the 10,000 hertz mark, a little bit lower, so, a couple decibels lower. Something like, I don't know, 3 to 4. You can argue about how you'd want that to be, but for me, this sounds very, very natural, has a nice, healthy amount of treble, just enough to give it a nice audiophile replay. And so this is really good. The bass hits just unbelievably deep and low on this thing. If we scoot over, we can see there's not a huge amount of roll-off. Speaking of roll-off, I had an absolute debacle I had to deal with, which is topping L70 amplifier, right? I don't have it on the screen right here or anything, but essentially what's going on is because topping, goes for benchmark scores, their input impedance on the topping L70 is actually 2,000 ohm. And wait, ohm? Yeah, it's 2,000 ohm. Typically, the sort of industry standard for impedance on inputs, which is not output impedance, but input impedance, is supposed to be about 50,000 ohms. So what we got here going on is basically topping, trying to get the best benchmark scores they could possibly get, but that means that most DACs that feed it, such as the Geshelli JNOG 2 I have, expect something more in the area of 50,000 to 100,000 ohm. So this is topping is way out of spec, and I didn't catch this in my last video. So just as of right now, the topping is off the recommended list. If you get a matched topping stack, that's one thing because the impedances there will be matched, but just using an off-the-shelf DAC, it's probably not going to be matched. So basically what happened was I had a shitload of impedance mismatch, and this graph shows right here the lows of the impedance mismatch between the L70 and the JNOG2. And honestly, okay, so before, well, this is 20 hertz, right? So below that doesn't matter that much, but we can also see that this is like 6 decibels lower at 20 hertz with the impedance mismatch. And so I freaked out, and basically I fixed it, but only not wonderfully. I stuck a buffer between the JNOG2 and the topping L70, which is the AUN B1S. So the AUN is feeding the topping with a impedance of about 2.5 ohm rather than the impedance coming from the JNOG at 50,000 ohm, which is fine, right? So there's no bass roll off. So it's a buffer. So anyway, what a debacle. Topping, tell you what. But it does sound extremely good like this. But anyway, so there's my 3D model. And I wanted to just show people this. So let's take the back plate off my model. So some of the technologies I have going on here, I'll just go over this. So we have this gap, right? The driver mounts right in this area here. It mounts onto this rim. So you can kind of see it right there. And the gap between the rim and this chamber right in here, you see this chamber here, the size of it matters greatly in terms of the upper, mid, and treble tuning. So from about 2,500 hertz all the way to about 8,000 hertz. This area right here is highly influenced by this gap in there. So the smaller the gap, the smaller the chamber, the more treble we're going to get in this area. The bigger the gap, the more dip we get in this area. But it also influences soundstage a lot. So I shrunk this gap to even smaller than this particular model, and the soundstage collapsed, and it gets really in your face. It's like a proximity effect, something close to that, but there's also Helmholtz resonator stuff going on. So anyway, if you're making your own IAM, this gap right there matters a drastic amount for dynamic drivers. And then if you have it in a chamber, well, that matters too. Anyway, so we can see that we have a gigantic front vent here. And the way that I kind of came up with that is sort of from the Twilight Mojo, where they have the gigantic front vents on Twilight. But also Axel Grell was talking about kind of impedances in the ear canal, and said basically that, and I agree with this, that the less acoustic impedance in the ear canal, the more natural things sound, because 99% of the time you're listening to sounds with no impedance, that is to say open ear canals. So if you can make a gap or an opening, right, where the sound is able to escape before it gets in the ear canal, that helps a lot. There's back waves that come backwards from the ear canal and the eardrum into the nozzle. And so if you have a nice fat vent, this one I think is like maybe 5 millimeter vent, and so that wave then can dissipate out that vent. Now, problem with that, of course, is that the vent then causes less sub bass, so you have to feather this. And then you might be wondering, well, what is this knob right here? And the knob is basically this thing here, is because I could not fit a snaky vent, into the front chamber without making that little guy there, and I'll show you how that looks. So there's our snaky vent on this particular model, right? It goes into that front chamber in front of the driver, and then right over here it comes out. And the reason why it's got this sort of feature, it's like indented. When I 3D print this, I have to put a syringe into this little section here and blow isopropyl alcohol through the snaky vent, which, like I said, looks like this. You can kind of see it from the side there. Comes right out that little knob there. And so I have to clear it out. That's why it's got this little indent. And then I have this circular form around it, which is for tuning, so I can stick a nice 2.5 millimeter damper into this area and tune the sort of the Helmholtz effect for this front chamber, because it's vented out of this. And the back plate, I edited this backplate. There is a gigantic vent like this one over here. So I'm just testing things. But so the air that comes out of that snaky vent then can come out of this big hole that's centered directly around the back of the driver so that sound can escape and not have wave buildup inside the shell. But you can tune with that, which this model is. I'm going to attempt to tune without that vent and see how that gets me. But this model doesn't have the venting inside like this one. Whoops. Right, it doesn't come out here inside the shell. It comes out on top of the shell right over here. So this snaky vent is much longer, and it looks like this. So it's sort of folded inside of the, inside of the shell. And you can see it's, I have to strategically place this so that the shell stays small, but I still get my snaky vent. Anyway, that's another way that I tried that. Also, for rapid prototyping, we have a screw feature here so that I don't have to tape or glue the shell. I just stick a nice screw into the back plate, and I can just screw it together, and we're good to go, and I can test things. I don't know if I'll leave that. I might, for DIY modders out there, I might leave the screw so that people can do whatever they want with that. But, that's a kind of a cool feature there. Just takes a couple seconds to open the shell, and then you can go and screw around. Also, just to mention this, this is the wrong model to check that on, but on the back plate, we have a place for a conical spring, which sits into this little guy here, and then pushes directly into the center back of the driver. So I can't really show that here, but if I go over to the, let's see, go over to the IEM, we can take a quick look here. Whoops, so there's our screw, right there. You can see the print marks on the shell quite easily. There's our snaky vent coming out right there. And this particular shell, I had two 1.5 millimeter vents on the front nozzle, and I decided that, well, for the tuning and just, trying things, I taped them over. Real easy to do. And then if we look through the back there, we can see the conical spring and the dampers on the back of the driver directly centered so that sound can go directly out and not mess around. Also features that might matter, and you'll have to excuse the schmutz on my damper because I've been reusing it quite a lot. But so that's the nozzle, and it's actually quite a chunky nozzle. It's 6.8 millimeter, which is big, but I find it to be okay. Hopefully other people do too. It's a feature of the tuning for sure. So I'll show you how that looks on the 3D model here. So let's go. All right, there's our nozzle, and I'm going to highlight the internals on it so you can see how that looks. And there's a little gap there, but you can kind of see the gap, by the way, is where the damper mounts. But so that's a horn feature, right? It goes from smaller to larger, and the flare for the tubing helps produce more treble, essentially, and a little bit more mids. So you can use that as a tuning feature rather than per se or different types of dampers that would go on the rim in here, just to mention that. So anyways, that's where I've been at with that. Here's our graph again. Actually quite a nice graph overall, and sounds very, very nice. I don't know. Usually the way this works is I'll get the tuning matched left to right, and then I'll mess around with it and take it out for a spin hiking and a couple days listening to it, and then decide if I really, really like it or not. And based on that, go make some changes with the shell, obvious stuff, really. But yeah, so that's what I've been doing for almost 2 years now. And rapid prototype shell, very easy to modify, change features on. I can put, like on this one, I can put a damper right over the top of this if I want to capture a little more subs. Same with these pinholes. And then at the end, when the final product is done, then I would possibly change these, maybe internalize them if I could, so that there's nothing to mess up. But yeah, that's where I've been. That's what I've been doing for a long time, and I just wanted to go over the features. Of course, this is the Dark Magician driver, 10 millimeter dynamic DLC coded driver. Also, just to mention this, my Discord group, everyone has been shitting their pants about VU meters. And so there's a bunch on the market. I don't really want to buy any more crap, but I did find this. So this is, Foobar, right? And Foobar has a bunch of plugins. So I found a kind of a nice one here, which is, fake VU meter. But, honestly, as you're listening to music and you see this thing dancing around, it's pretty cool. I like it. It gives you a little bit of extra mojo with your music, and it definitely sounds a little better. They have a bunch of skins. You can try different VU meter skins. This one is like a stereo one. Clearly vintage. They're all vintage at this point. But cool. So yeah, and as far as the tuning on this goes, I think that here's the problem with this driver, honestly. So this has, like I said, 6.75 decibels of ear gain. But the problem with this driver is actually it has such heavy mids that that's as much as I could ever go with this. And probably it'd be better around maybe 5.5 decibels of ear gain. And possibly not quite at 2.4. I'm thinking maybe 2.6 might be a little better for that peak. The shelf would come a little bit more shallow here. But right now it's not bad. You can combat that with the extra mid bass and bass in this area for sure and balance that out. I find the treble to be very, very nice on this. Just overall extremely nice. Relatively shimmery, but excellent detail, very natural. Just wonderful treble. And if there's one thing this driver does well, it's got to be that it has some amazing, amazing treble for sure. And the stage has got to be the other thing. So staging on this is what I would call better than average, actually better than good. It's nearing excellent, but not as good as some of the other tunings I've done, which have more problems, such as too much mid bass. So you get a little bit of a haziness to the tonality, whereas this is relatively nice and clean, has excellent subs. The ear gain is matched well with the mid bass in the subs, and the treble is pretty much right in the pocket. So I like this a lot. The question is whether or not it's good enough, and I don't know yet exactly. But right on, and I will talk to you on the next one.